What's up, ladies and gentlemen? My name is Anurag, and you are watching Think Wild. So, once again, I will welcome you to the new year 2025, and I am wishing you a healthy and wealthy new year. So, for the wealthy thing, uh, I am planning to create a new playlist on financial education as well because I have spent a lot of time in the stock market and commodity market myself, and I have learned few things by making some losses, making some profits throughout my journey. And I will be sharing my opinions and thoughts on financial education this year as well, because I think our education system does not teach us these financial things from our childhood. Otherwise uh, I would have in better place myself. So I thought you should not face the same thing which I faced in my education, and because of that, I will be coming up with the new and interesting videos with financial education as well. For now, the philosophy of Think Wild is that we explore the intersection of art and technology. So I will be sharing you with I will be sharing with you a kind of Python script in biosimulation. And biosimulation means we are going to simulate a forest kind of environment with an organism, and particularly a bear, a grizzly bear. And for for this series, I think this is a little bit longer video, so this can be a longer video. So I will be splitting into it into few parts. I'm not sure how many parts it will come, because I am already in the process of writing the code on the fly. So for now, I have created an environment, an organism, a bear, our bear, and a few berries which are across the forest. And the fundamental idea behind this simulation is that our bear will be going through the forest and finding the nearest berries uh, around its location, and it will try to eat it. So we have two kind of berries in our forest, red berry and green berries. So as the colors color suggest, green berry is a food for him, and red berries are toxic to him. So I'm saying my bear as a him because I am assuming it's a male, and so there is no confusion in pronouns like they or them, she or her. No, it's our bear is a he and him. Okay, so that bear is roaming around the forest and eating the random berries as of now. But I'm planning to, like in our second videos, we will be giving him a little bit of brain, which if you can see my screen, I have written simulation.py and brain.py. So in brain.py, that script is still under progress, and I will be sharing you both all the three codes and data set as well as on my GitHub. So in the brain, what it will do that it will learn through machine learning algorithm, and I have selected the machine learning algorithm as KNN. It's K nearest neighbor algorithm, which is very straightforward and very simple for our learning. So what does it do? That it will roam around the forest and see the berry, and it does not know that is a food or poison as of now. But in future videos, it will be knowing that it will be sending the attributes of the berries to its brain through his eyes, and analyzing it and concluding that it's a food or a poison to eat it or not. Okay, so that's for the next video. But for now, we have created a simulation for the environment, for the forest, and a simple bear organism. For now, the bear finds its the nearest berries and eats it, whatever the color is or whatever the type of berry it is. And for if the berry is green in color, it gets fatter, its health increases. And if berry is red in color, or we may say it's a poison, the health of the bear decreases. So I think before describing the code, I should describe the our data, from where it came and how it looks like. So we are taking our data from forestdata.csv. It's you might have seen the data before as well. I have modified it a little bit, and if you are a little bit familiar with the scikit-learn and Python libraries, machine learning libraries, you might be knowing about iris data, iris flowers data. So I have taken that iris flowers data and considered that iris flower data have three kinds of species inside it. I think Iris setosa, versicolor, and virginica. I think these are the species name. So I have removed the third one because it's not linearly separable. For the sake of simplicity, I have taken two species of that flower, and which are linearly separable. And one of them is considered as a food, and one of them considered as a poison. So this 5.1 and 3.5 that you are seeing is actually the sepal width and sepal length of the original data set. It contains two more features like petal length and petal width, but for the sake of simplicity, I have removed them and I'm using the same data, but not in the terms of flowers, but in the terms of our berries, the food or the poison, the red berries or the green berries. So first two features are sepal width and sepal length. Third one I have added as a food or poison. So for the 50 instances of the data, it is food, and for the 50, it is a poison. Okay, so and the next two parameters are x and y coordinates, which we'll be using to spread it across the forest. We will be visualizing all the environment, and this x and y coordinate will be used to spread our berries on the forest. The last column 1 and 2, you can remove it as of, you can ignore it as of now because it's a class label. So 1 belongs to food and 2 belongs to poison. So I hope our data set is clear now. Now we can go to the coding part, and I can explain. I have already written the code. I can explain function by function so that what is going on, and then I will go to the demo. So here are the imports. Then comes the bear class. Our bear class contains only three attributes as of now. It might increase in future, but as of now, it's contain the x and y coordinates of the bear and the size. You may consider it as a weight. Okay. The another function is another method in the bear class is distance to. So what does it do? That it takes the distance between it calculates the distance between 2 points. So majorly in our case, the interested points is a bear and the nearest berry. And another function is move towards. As the name suggests, this will change the coordinate of our bear from the current coordinate towards the nearest berry. So it's kind of we are finding the dx and dy, the delta and dx and dy, the delta between x and y coordinates, and doing some mathematical steps and moving it towards the uh, nearest berry. So if you can see the line number 20 and 21, it's nothing but we are finding the uh, unit vector between the 2 points and moving our target vector step by step to our destination point. So that's whole is going on in move towards forward. It will change the vector of current position of bear to the nearest point of berry. Okay. Next class is the class dot, with which the term I'm referring to berry is actually this class dot. Okay. So it has a few more parameters than the bear class. So it has coordinates, the size, the sepal length and sepal width, which I was talking about, and the food type, which is coming from our CSV file, and we are assigning the color for the sake of visualization. So I think it's clear till now. Now, what we will do, that we will open our CSV file and initialize 100 instance of this dot class in this line number 48. So we are going through the loop of our file, and we are initializing with these values: sepal length, sepal width, food type, and x and y coordinates from our file to a list of dot, or we can say a berry type of object. Then we initialized our bear with the initial value of 5 comma y. 5 means that it will be on the x-axis 5 units, and on the y-axis 5 units. So it will be on the corner of our forest, and it will enter towards our forest towards the nearest berry. So our next function is it's outside of the class, the find nearest dot, or we can say the find nearest berry. It will take the arguments, two arguments. One is the berries coordinates and the bear's coordinates, and it will find the nearest dot across all the data sets we have initialized from our file. After that, we are doing just a visualization kit. I have visualization case. I have used Seaborn library so that we can visualize it how our bear dot is moving towards the different berries and how it is behaving. And then comes the update function. This is used for animation. So what does it do? That it finds the nearest berry and change the bear's coordinate towards the nearest berry. So this step size is actually the number of units on the Cartesian plane, how it is moving. It will move one dot one by one in our x and y plane. This if condition is doing that whenever a green berry is reached by a bear, the size of bear we will increase by 5. Let's say it's a food. It's If it is a green berry, it's a food for him, and it increases his weight or increases his size. I have not implemented the decrease in the size as of now because I am planning to include it in the brain, so that because if I do include the decrease in the health, then what will happen? Unluckily or maybe luckily, the bear might be because these berries are spread randomly across the forest. The bear might go to all the red berries in the in its initial stage and might die. So to prevent that dying condition, I have only included the increase in health, not considered in the decrease in health. We will be considering that decrease in health in our machine learning algorithm when we will be giving the brain to our useless bear. Okay, so once the bear reaches threshold, that this is the 2 unit, the when the bear reaches our berries which very close, it we increases the size of the bear and remove the our berry from the our original data set. So in the next frame of the Seaborn uh, chart, that berry disappears. So so we can say that the bear consumes it, the bear eats it, and the berry disappears from our plot. These 4 5 lines are nothing but for the animation, and these 5 lines are for plotting the chart and animation. So I think I have explained quite uh, of the code. Now let's go to the execution and see how it looks like on the chart. So I will write Python simulation.py. Meanwhile, I will be explaining while it is running. We'll explore more of how it is working and what the bear is doing. So this gray dot color is our bear. It is moving toward the forest. It's outside. I'm not sure where it is, but it's moving toward the forest. It ate the green berry. It ate the red berry, and whenever it eats a berry, its size is increasing by very small amount, the 5 units. So for now, as I said already, it's not considering the color or the type of berry. It's a food or a poison. It's just consuming and increasing its size. In the meanwhile, in the coming videos, we will be creating, we will be giving this brainless bear a brain to understand, to learn that if he eats red berry, he get ills or his health decreases, and if he eats green berries, his health increases. So our assumption, our expectation from the whole simulation when the whole projects end is that our bear will not eat the red berries, instead only eats green berries and keeps on growing. So that's the whole target of our project. I'm thinking that while implementing this project, you might be learning multiple technologies like Seaborn, machine learning, and Python itself as well as. So I personally feel this project is very interesting, and you can learn multiple modules of Python by implementing this project, and it will help you in your upskilling in 2025. So as you can see, it ate all the berries, and very few berries are left now. We will wait till it eats all the berries, and the forest is come cleaned by cleaned by this our brainless bear. So only one berry is left. It's moving towards the last berry. It does not know as of now it's a poison or a food, but it's anyways going to eat it, and our program will close. Okay, so yeah, it's closed now. So this is the first part of our machine learning biosimulation. I will be coming up with the second part, as I said, and we will be giving this bear a brain, and the whole simulation will complete in subsequent parts. So I hope you have learned and enjoyed this interesting project and will try to implement uh, yourself. I will be uploading this code and this data set on my GitHub. You can take it from there and explore it yourself. So I think that's all from my side for today. Uh, so we can log off here and thank you for watching. Goodbye.